Hello, hi. I am Dr. R. Chander, Assistant Professor in Department of Tribili in Marri Laxman Institute of Technology and Management. Today we will be discuss power quality and facts subject. This subject is final year second sem and the main topic is power quality issues and subject code is 2280245. And this is the lecture number 2. Last video will be discussed and power quality issues. Some issues already discussed. Now the continue issues in power quality issues. So let us consider the main definitions of power quality. The power quality is an problem manifested into the voltage, current, or frequency deviation that result in misoperation or failures of customer equipments. That means, for example, see here, this is the sine wave. So here, when you connect the load, the voltage is same wave, same sinusoidal. There is no disturbance. For example, whether this is here in this point, some disturbance is there, it under comes the power quality issues, whether voltage shock, swell, or harmonic distortion, or some DC offset like this. So when you got the purely sinusoidal, there is no power quality issues. So we will discuss one by one. That is voltage shock, or you can call the dip. The main voltage shock is a short duration. This occur only short duration. That is mean what is meant by short duration? That is 0.5 to 60 seconds, 60 cycles. So the voltage shock is a short duration. That means 0.5 to 60 cycles decrease in the RMS voltage magnitude. That means decrease the voltage in that only short duration, that is 0.5 to 60 cycles. And voltage shock are the most important power quality problems facing any industrial customers. This problem is any industrial, this problem may be occur, the main. And your shock is when the voltage drop below 90%, that is dropped below 90% of normal voltage. This under come the voltage shock, or you can call dip. So next one is causes. The main causes of voltage shock, that is faults on transmission or distributions network, fault in customer installations, and connections of heavy load and shut-up of large motors, switch off large reactive power sources. This come the causes in voltage shock. And next, the main effect of voltage shock is malfunction of equipment used in model industrial plants. Any industrial plant can use process controller and PLC and variable speed drives. Use actually became more sensitive to voltage shock as complexity of equipment increases. So any industrial are used PLC and variable speed drives. You see the right side of the waveform. See here, this is the waveform. When the voltage is increased like this, for example, this is the normal voltage. When you can disturbance occur in the your low or disturbance occur in the plant, that is the voltage will be decrease like this. The voltage will be like this. This is under comes the voltage shock. Again, the voltage will be normal position. The duration is 0. This is the 0.5 to 60 seconds. That is a short duration. This can be occur only short duration. This is under comes the voltage shock. And next to coming to voltage swell. This is the under come the voltage power quality issues. That is, it is a short duration phenomena increase in RMS voltage. This is increase the RMS voltage. And voltage magnitude lies between the 1.1 to 1.8 per unit. The voltage magnitude is 1.1 to 1.8 per unit. The durations of event range from, this is also 0.5 cycle to 60 seconds. This is also voltage shock, short duration. And causes of voltage swell, switching off of the large load. And the main effect of voltage swell is the malfunction of electrical low voltage devices and malfunction of measuring and control equipment. So see here, right side of the waveform, this is time versus voltage. So here up to starting voltage is normal voltage. Normal voltage. Sometime that is 0.05 to 0.10. The voltage will be decrease like this, decrease. The duration is 0.5 to 60 seconds. This is also undercome the voltage shock power quality issues. See the like this. So this point to this point. The duration is 0.5 to 0.5 to 60 seconds. This is under comes the voltage shock power quality issues. Next one is, I can explain transients. This is also power quality issues. It is short duration phenomenon. That is, see here, right side of the waveform. This is the voltage like this. Normal voltage. When some disturbance occur, that is in waveform, here the disturbance will be occur. This point you can call the transient. You can call the transient. This is the power quality issues. Next one is impulse transient. An impulse transient is defined as sudden changes in the steady state condition of voltage or current. Sudden changes is there. When the sudden changes, the impulse transient will be occur. See here, right side of the waveform, this is the sudden changes. This point you can call the impulse transient. And next one is oscillator transient. This is the undercomes the power quality issues and sudden and power frequency change in the steady state condition of voltage or current that bidirectional in polarity is shown in the figure. See here, right side of the figure, I draw the small waveform. So when some disturbances occur, like the voltage waveform will be disturbance. Like see here, maybe increase or decrease, positive or negative. This point you can call the oscillator transient. this point, up to this point to this point. This is called the oscillator transient. And next, coming to short duration versus interruption. So here the complete loss of voltage on one or more phase conductor for a time less than 1 minute. This is the short duration variation of interrupts. See here, right side of the waveform, see here, some disturbances occur. When you connect the load or we can on the switch, some issues is there. You can show the voltage. See here, this is we can disturbance. You can call the interruption within short duration. Next, I will explain voltage imbalance. So this is the phasor diagram for voltage imbalance. And a balanced sinusoidal supply system, the three-phase line neutral voltage are equal to magnitude and are phase displaced from each other by 120 degrees. You know that the total is 360 degrees by 3. For balance condition, the phase displacement is 120 degree. For balance condition, you see the vector diagram VA, VB and VC. This is the balance condition. The phase angle is 120. Here also 120. Here also 120. Phase angle difference. Phase degree is 120. So you can call the voltage imbalance. So this is the balance condition. Next, coming to imbalance. So any difference that exists in the three-phase magnitude or shift in phase separate from 120 degrees is said to give rise to an unbalanced supply. We can call the unbalanced system. You can see the vector diagram right side, VA, VB and VC. So VA is more, VB is less and VC also more. So the magnitude will be different. This is under comes the unbalanced impedance. Unbalanced. See here, the vector is, so the angle is 120, but the magnitudes will be different. So this is called unbalanced. So you can see the right side of the three-phase voltage waveform. So let us consider this is the VA, this is VB and this is called the VC. So where VB, VA, VB, VC are the phase is unbalanced. Unbalanced. There is no equal voltage. So you can call the unbalanced. And next, coming to voltage fluctuation. You can say voltage fluctuation can be described by a receptive or random variation of voltage in envelope due to the sudden changes in the real and reactive power drawn by load. The characteristics of voltage fluctuations depend on the load type or size and power system capacity. So we can see the waveform. We can observe that this waveform, the voltage waveform, whether increase and decrease, like step wave. Voltage envelope, see this you can call the voltage envelope. This is the voltage waveform. There is no constant. The fluctuation will be there. So this under comes the voltage fluctuations. Okay. Next, I will explain some definitions, terms and definitions. That is power quality. Power is a duration of the voltage or current waveform from its normal sinusoidal wave shape. Voltage quality. Voltage quality is mean by deviation of the voltage from a sinusoidal waveform. Current quality. Deviations of the current from sinusoidal wave. Impulse transient. A sudden or non-power frequency changes in the steady state condition of voltage or current that is unidirectional in polarity. Next, oscillatory transient. A sudden or non-power frequency changes in the sudden steady state conditions of voltage or current that is bidirectional in polarity. You can call the oscillator transient. And DC offset. The process of a DC voltage or current in AC power system. Next, coming to noise. So noise will be occur, that is an unwanted electrical signal in the power system. For example, see here I can draw the small waveform. So this is a normal waveform, sinusoidal. So disturbances occur, we can call the unwanted electrical signals, or we can call the noise. There's long duration variation. That is a variation of an RMS value of the voltage from normal voltage for time greater than the 1 minute. This is long duration variation. And short duration variation. A short duration of the RMS value of the voltage from normal voltage for a less than 1 minute. This is under come the short duration variation. And voltage shock. Shock is a decrease in RMS value of voltage or current for duration 0.5 cycle to 1 minute. And under voltage, the 10% below the normal voltage for period of time greater than 1 minute. It is under come the under voltage. Next, over voltage. So here the 10% above the normal voltage for period of time greater than 1 minute. We can call the over voltage. And next, voltage fluctuations. The cylindrical variation of the voltage that result in flicker of lights. You can call the voltage fluctuations. And voltage imbalance. The three-phase voltage differs in magnitude. We can call the voltage imbalance. Harmonics. It is a sinusoidal components of a periodical wave or quantity having frequency that in an internal multiple of the fundamental power frequency. It is called the harmonics. And distortions. Any deviation from the normal sine wave for an AC system or AC quantity, they can even call the distortions. And next, the total harmonic distortions. That is the ratio of root mean square or RMS square of the harmonic contained to the RMS value of the fundamental quantity. This is total harmonic distortion. And interrupts. So the complete losses of voltage on one or more phase conductors for a time greater than 1 minute. This is called interruption. No, this is the references. Thank you. Thank you.